So what questions do you have on this homework? Anything you want me to do? 26? All right, let's do 26. So 26 says sine is supposed to equal cosine times tangent. Now, by the way, from here on out, all those little theta symbols, yeah, don't worry about writing those. All right, what can we replace sine with? X, y's, and r's. Y over r. All right, not a whole lot we can do with that anymore. What's cosine? X over r times tangent would be y over x. Well, multiply. What happens to your x's? They go. So those just go away. And then all you're left with is y over r. Woohoo! And you're done. 16? All right. So 16 says cosine of negative 120 degrees is supposed to equal cosine of positive 120 degrees. All right, well, what's my reference angle for negative 120? 60. What's cosine of 60? Middle column, bottom one. 1/2. 0.5. Come on.
That's what it says.
Use your brain, not the calculator. All right. Now, remember, a negative 120 only is going to affect the quadrant, because negative means we go down, so we're third quadrant. Is cosine positive or negative in the third quadrant? It's negative, right? Cosine's positive in the right two quadrants. All right, cosine of positive 120. Well, reference angle would still be 60, so cosine of 60 is 1/2. This would be in the what quadrant? Second quadrant. Cosine is also negative in the second quadrant. Woo! Is that all? Someone said another one. What you got? 22? So we got 1 plus cotangent squared is supposed to equal cosecant squared, right? All right, well, can't really do much with the 1. What's cotangent? Tangent is y over x, so this would be x over y squared, so they're both squared. Cosecant is the reciprocal of sine. Sine is, so this is going to be r over y. Again, both squared. All right, this is going to come up a lot. You're going to get to a situation like this probably 50 times in the near future. Got to get them to match. So left side I have 1 fraction. Right side I have 2. I either have to figure out how I can turn 1 into 2 fractions or 2 into 1. Which would you like me to do? To me, usually 2 into 1 is the easier method. So, but I'll do both. So to go 2 into 1, basically you need to find a common denominator. What's your common denominator? Y squared. So this is going to turn into y squared over y squared, right? So this would be y squared. That one doesn't need to change because it's already... And then what can I do? What is x squared plus y squared? That's r squared. Woohoo! That's one way you could do that. Or, if you wanted to, you could have worked on this side and is there a substitution I could have made for r squared? What does r squared equal? X squared plus y squared. So you could have woohooed here and done that. Or you also, from this point, are allowed to split that. That is the same thing as x squared over y squared plus y squared over y squared. Basically undo the fraction. Right? Put each part under the common denominator, and then that's just going to turn into a what? 1. So you could have done it this way, and matched to there. Which way is the best way? Whichever way makes sense for you. Like that really is. It comes down to you got to get from point A to point B. Please, please, please make sure you understand as we go through these proofs. What is the one and only thing that you can do to get points? What's the only way I can give you points? They have to match, but they also, I have to be able to follow your logic. Guys, there's going to be times, and I've been teaching this for a long time. Do you think that every once in a while I get a student get to a weird point and go, I don't know what to do here, so I'm just going to do this? Woo! Is that going to work? They match, but what did I just do? I didn't know how to get them to match, so I just wrote the other side over here and called it a day. Well, that to me is what I consider a big step. And sometimes it's a really, really big step of, yeah, you really needed like 4 steps to get there. This one really is more of a big, like a 2-stepper that you're trying to squash into one. That's where I start nickel and diming you. And going, all right, that was a little bit too big of a step there. And that's where you're going to start losing some points. And then depending on how many steps I really thought you skipped, that's how many points you're probably going to lose. Okay? So make sure, when in doubt, should you have extra steps or fewer steps for these? Extra, because I'm not going to dock you for having too many points, but I am going to dock you if I think you jumped a little too far. To me, this basically just screams, I didn't really know how to get there. I just wrote the other side so I could be done. Okay? So yeah, that's pretty common, and yes, I'm always on the lookout for stuff like that. Okay? Anything else from the homework? Yes, 18? Tangent squared, 3 pi over 4, supposed to equal secant squared. Come on, pen, stop it. 3 pi over 4 minus 1. All right, what is 3 pi over 4 as a degree? That's the first thing I would do with this is, what is 3 pi over 4 as a degree? Well, pi over 4 is 45. 3 45s would be, that's 135. What is tangent of 135? What's tangent at 45? Third column, right in the middle. That's 1. Now, we are squaring it, so this is an irrelevant question because it doesn't really matter. But 135, what quadrant, so I can figure out positive or negative? 135 is second quadrant. Tangent in the second quadrant is negative. Again, that was an irrelevant question because I'm squaring it anyway, so either way it would have been 1, right? But yeah, just to do it properly, it would be negative 1 squared. Okay. Secant squared. What am I hoping this whole thing is? 2. I'm really hoping it's this, right? So, because I got a minus 1, get to 1. What's secant of 45? Well, secant is the reciprocal of cosine. What's cosine of 45? Square root of 2 over 2. What's the reciprocal of square root of 2 over 2? Square root of 2. And then again, positive or negative, irrelevant because we're squaring it. But second quadrant, cosine of the second quadrant is negative. And then, yep, negative square root of 2 over 2 or negative square root of 2 squared would just be 2. 2 minus 1, 1. Can you use those kinds of ideas where I'm kind of working it backwards to help me? Yes. Guys, I'm telling you right now, every proof you do in this next section and the section after that, there's going to be one underlying truth that should be your saving grace, or could be your saving grace. They all work. They should work. If you sit down with a puzzle, knowing your brother or sister has already completed this puzzle, you know it goes together. All they did was they moved all the pieces around. Well, should that help you in certain ways? Yeah, I know this works. Now, if your little brother or sister is like my sisters, and they had put the puzzle together before, now, what do you think my sisters would do to me? Nah, they would take some pieces out to really mess with me, right? Now, if that was the case, and I didn't know that was a true statement going in, that makes that puzzle a whole lot harder, right? Now, we'll get to those eventually, but right now, everything we do, you're going to go into knowing this should work. Okay? All right, we good so far? Anything else from this homework assignment? 28. Sine squared equals 1 minus cosine squared? That one's very similar to the other one I just did with the x, y, r. Sine is y over r, so y squared over r squared. Cosine is x over r, so x squared over r squared. Did you like the 2 into 1 or 1 into 2 method? 1 into 2? All right, well, what's y squared? In your x squared plus y squared equals r squared, this is the tool you're using, right? What would y squared equal? Get the y squared by itself. It would be r squared minus x squared. So I can make that substitution if you want. That would be x squared minus r squared over r squared, right? Because we replaced the y squared with what it's equivalent to. And then you would separate that, which would be, I wrote that backwards. That was an r squared minus x squared over r squared. Now you rewrite it as two different fractions, which would be r squared over r squared minus x squared over r squared, and then that just turns into 1. That's how you would do it if you wanted the 2 into 1. 1 into 2, you would just do common denominator, which would be, that would have to be r squared over r squared. I would make the substitution right from here to y squared. Some people would still choose, I don't want to, I don't want to know this tool in multiple forms. I only want it in the standard form, so I would replace the r squared with x squared plus y squared. And then the x squareds cancel, and you get to there. So, guys, there's lots of ways you can do this. And that's really the idea. What is the benefit of being able to take your tools like this and know it in multiple forms? What's really the benefit of being able to do that? What's the benefit of knowing all your tools in multiple forms? Makes your life easier. It makes it where you can make easier substitutions. it's going to make it to where you recognize substitutions better. If I were you right now, on a sheet of paper, I would open in my notebook to a blank sheet of paper. I would open my book to page 133. And I would use this entire sheet of paper. And basically what I would do at the very top of my piece of paper is I would write toolbox. And then I would write reciprocals. And if I had multiple colors, colors would be really helpful. But what's the very first reciprocal identity on page 133? Is that the secant one? Secant or cosecant? Cosecant. All right, so it says cosecant is equal to 1 over sine. I might put that in red or pencil or black. And then I grab a different color. And I would write multiple versions of that. Like cosecant times sine is equal to 1. And then I'd write sine is equal to 1 over cosecant. And then I would go back to my black pen or whatever color you want to use. And I'd write the next one of secant is equal to 1 over cosine. And I would do that for my own benefit. Because this would be the cheat sheet, basically, that I would use to do my homework. And if I have not just the basic identities, but if I have multiple versions of that, and why would colors be helpful there for your other versions? Because now it becomes easier to see, and if it's all just one color, everything's just going to get jumbled. It's going to end up, is this going to end up being a lot to look at? Absolutely. Where colors would help your eye go, all right, these are my main identities that I have to know. My blue ones are the ones of just other versions of it that I can kind of be on the lookout for, and the better I know those, the easier they are. I will tell you, the better you know these trig identities, the easier these proofs are going to be. When it comes time for the test on this stuff, if you can't just take a piece of paper and easily write all the main trig identities, you're going to really struggle on the test. You really are. Because if you're constantly having to look back, like when you first start these, you're going to look back at your cheat sheets. You're going to look back at your note page that we're talking about doing this. You're going to look back at the book, page 133, a lot. When you first do a few of these, you're going to do that. But you have to start getting to the point of not looking. Because the faster you can get to there, when you're in the middle of a proof, the faster and easier you'll recognize substitutions when you should see them. Does that make sense? So that's the first thing I would do. On a sheet of paper, I would just simply write all those out. Okay? It's basically the exact same thing you did for the first couple homework problems of last night, right? Easy? All right. There's some other basic skills, and you can do this. This is not, do you have to do this in your notes toolbox? No, I'm not saying anyone has to do this, but I personally would. And if you want during AAA for me to walk you through and actually help you create a really nice one-page cheat sheet of all those different ones, I absolutely will do that. Okay? Now, some other things you're going to have to be able to do. I said you better know how to factor. What does that factor into? No. That's the difference of two squares, so it's x plus 2, x minus 2. Yes? Everybody good with that? Dude, I hate my pen right now. If that factors like this, what do you think sine squared theta minus 4 factors into? sine plus 2, sine minus 2. Easy? What does x squared plus 5x plus 4 factor into? What? X plus 1, x plus 4? Yes? Well, fine. What does cosine squared of theta plus 5 cosine of theta plus 4 factor into? It's going to factor into cosine of theta, which you don't have to write the thetas anymore, plus 1 cosine plus 4. They work and they're going to factor exactly the same way as we factored in Algebra 1. If you can factor x squared plus 5x plus 4, then you can factor cosine squared plus 5 cosine plus 4. It's going to factor exactly the same way. 75% of these proofs, seriously 75% of them roughly, come down to situations like this. You'll get something that looks like this. Tangent squared minus 1 over tangent squared plus 4 tangent plus 3. What do you think I should do? Factor. What's my numerator factor into? Tangent plus 1, tangent minus 1. That's the difference of two squares, right? What's the denominator factor into? Tangent plus 1, tangent plus 3. What happens? Plus 1's cancel, and I'm left with just that. 75% of proofs come down to simplification. Just being able to factor out and cancel everything out in 75% of the time, you're done. Like, that's all you have to do, is just simply simplify. Now, there's a type of factoring that I'm really curious to see how good you guys are at. Do you remember how to factor x cubed minus 8? A difference of two cubes. Anybody remember how to do this? There's a rule for both the difference of cubes and the sum of cubes. Anybody remember doing this? No? All right, so it's real simple. What this factors into is this. What's the cube root of a to the cube? A. Cube root of negative b to the third. That'd be negative b. So you take the cube root of both. Okay? And then you square the first, opposite the product. So if I multiply those together and opposite that, that would be plus ab. Yes? Second one squared. So you take the cube root of both, you square the first, opposite the product. Does everybody see what I mean by opposite the product? And then you square the second. Plus works exactly the same way. What's the cube root of b to the third? Or a to the third? That'd be a. Cube root of b to the third would just be plus b this time. Yes? Square the first. Opposite the product. What comes next? What would opposite the product be? minus AB this time, second one squared. Everybody good so far? If you don't remember that way of factoring, you might want to write it down. So what would x to the third minus 8 factor into? What's the cube root of x to the third? X. What's the cube root of negative 8? Minus 2. So it'll be x minus 2 times square the first, opposite the product, plus 2x, second one squared, plus 4. Everybody good with that? Does that make sense? Now, where we will see that is, let's say you have something like this. What is sine squared minus 1 divided by sine cubed minus 1? What do I have to do with both the top and the bottom? Factor. What's my numerator factor into? Sine minus 1, sine plus 1. So far, so good? What's the bottom factor into? It'd be sine. I take the cube root, take the cube root of negative 1, which would be negative 1. Right? And then you square the first. Opposite the product would be, say that again? No, because that's a negative. Cube root of negative 1 is negative 1. And then, what?
On the bottom, it's A minus B, right?
If this is minus, this is minus. If this is minus, the first one's minus. Everything over here should be plus. If it's plus, then there's always one negative, and if it's plus, the negative goes in there. Remember? Okay? So that's negative, so the negative goes here, and then it should be plus 1. What's left to do? Cancel the sine minus 1s, and I'm just left with sine plus 1 over sine squared plus sine plus 1. Here's what a proof will look like. They'll give you this on the left side. On the right side, they'll give you sine plus 1. Come on, pen. Sine plus 1 over sine squared plus sine plus 1. Ta-da! You just did a proof. There's a lot of times when all you have